So to explain square roots, I'm going to start by explaining squares. So we know what a square looks like. It's that four-sided figure where the side lengths are all the same. To find the area of a square, that is the square of a side length. Meaning, like right here, I would say that is 2 squared, because what I mean is the area of an object we'd say is side times side, right? Length times width. Well, in this case, length is the same as the width because it's a square. All sides are the same. So 2 squared, hence that's why that's called squared, means 2 times 2. 2 times 2 means we know that the area of this square is 4, is the area, units, whatever the units may be. So try to tell me then, you know that the area of this square right here, it's not 0, some number goes inside there. What do you need to do? You should say, okay, well that's squared because this side length is 4 also, right? So we say that's 4 times 4, which I hope we can all tell me means it's not 15, it's 16. Good job. Okay, so 16 units, and whatever the units may be. So those are squares. Now, let's think about what a square root is. If I'm going backwards at 4, and I say the square root of 4, that means what number times itself gives you 4? Well, since we just did that, going backwards means that 2 times 2 is the square root of 4. So therefore, 2 is the square root of 4. Okay, so again, let's do the square root of 16. Going backwards, we know that that's 4 times 4, which means that 4 is the square root of 16. Make sense? Certain square roots, like square root of 4 and square root of 16, are called perfect squares. That's because they work out to a nice even integer. There's other numbers. It's not just the square root of 4 and square root of 16. Like, what's the square root of 64? So think about it for a second and think about what times itself is 64. You should be able to tell me that that's 8, right? Because we know that 8 times 8 is 64. Again, that's a perfect square. About the square root of 121. I hope you can tell me that that's 11, because we know that 11 times 11 is 121. So those are all examples of perfect squares. Now, please pay attention, though, if you see something like this. If you see the negative square root of 121, you know that that is negative, because all that means is this is outside of, think of the square root sign as kind of like a grouping symbol. Do everything inside of it first. And when we learn with order of operations, we do everything here and then this. So this says, like, subtract the square root of 121. So instead of thinking this as negative 11, what it means is the opposite of 11. So the negative square root of 121 is negative 11. So what happens when you get a number that's not a perfect square? Say I get the square root of 8. Now what I need you to do is think about, well, what would be the two integers that it's between? So you think about what numbers you know the perfect squares of, so meaning like, what's the square of 2? Well, 2 times 2 is 4. What's the square of 3? 3 times 3 is 9. The square root of 8 has to be somewhere between 2 and 3 because the number 8 is between 4 and 9. Make sense? I'll give you another example. Let's think about the square root of 20. Okay, think about what you know. 4 squared, 4 times 4 is 16. 5 times 5 is 25. The number 20 is in between these two. So we know the square root of 20 is somewhere between 4 and 5. Now, that's not all you need to do, but that's a good way for us to get started is to know at least what the integer is that we're dealing with. That leads me to talking now about rational and irrational numbers. We've learned about rational numbers. We know that a rational number can be written as the ratio of two integers, meaning like 5 can be written as 5 over 1, correct? We can take a decimal, write it as a fraction, meaning a rational number, the decimal either repeats or it terminates. So 5.555 and repeating, that is rational. Also, 5.25 is rational because it ends. A number that would be irrational is like pi. We know that we say it's 3.14, and then so on and so forth, right? And then we kind of end off somewhere. It never ends. An irrational number does not end and it does not repeat. It cannot be written as a ratio of two integers. So let's do some examples of rational and irrational numbers. So the square root of 1 we know is 1 times 1. The square root of 4 we know is 2 times 2. Okay, what about if I said the square root of 2? Don't try to tell me it's like 1.5. No, it's actually irrational. The square root of 2 just goes on forever. You'll say it's 1 point and then just go, and you'll never end. That's irrational. I'll give you another one. Square root of 18. It'll just keep on going, and then you'll just never end. So those are irrational numbers.